All right, today we're working on Chapter 3, Section 3, which is solving inequalities by multiplying or dividing. First, I want to take some notes, though, so write this down. If you multiply or divide each side of an inequality by a negative number, you reverse the direction of the inequality symbol. So the kinds of problems we'll be doing are things like this. 4x is greater than 40, and we want to solve for x. But before we get to that, I want to highlight a few things in the notes that you took. First of all, it's only if you multiply or divide. Also, only if you multiply or divide each side and by a negative number. So only if all three of those apply. You multiply each side by a negative number or you divide each side by a negative number, then you reverse the direction of the inequality symbol. And what I mean by that is simply if you have greater than, you flip it to less than, and vice versa. So let's go back to that example. 4x is greater than 40. Remember, this is just like as if it were an equals. 4x equals 40, but it is a greater than sign. We still do the same thing, though. We separate the two sides. The x is on the left along with the 4, and it's attached with multiplication, so we divide by 4. And remember, whatever we do on the left, we do on the right. That way the 4's cancel. I bring down the x, and then stop. You have to ask yourself these two questions every time. Did we multiply or divide? Yes, we did. We divided right here, you can see. Did we multiply or divide both sides by a negative number? Obviously not. We divided by a positive 4. If both of these answers were yes, then we would flip the inequality. But since this is yes and this is no, our inequality stays the same, and then 40 divided by 4 is 10. So we think that the answer is x is greater than 10, and just like the last lesson, you have to check both the answer and the inequality. So when we check the answer, remember, we're just picking 10. We're plugging in 10 in place of x, which is what I'm doing right here, and I want to see if that's equal to 40. Well, clearly 4 times 10 is 40, and that's a true statement, so far we're good. Now to check the inequality. I have my answer here, x is greater than 10. That's what we got for the answer. So we want to choose any number that's greater than 10. 11, 12, 13, whatever it is. And then we plug it into our original problem. So I'll choose 11, 4 times 11. And we want to see if that's a true statement. So 4 times 11 is 44. And that is greater than 40, so that's true. We did it correctly. In the next example here, negative 9t is less than 36. Again, separate the two sides of the inequality. The t is on the left along with the negative 9, and it's attached with multiplication, so we divide by negative 9 on the left, and whatever we do on the left, we've got to do on the right. That way the negative 9's cancel, bring down the t, and then stop. Did we multiply or divide? Yes, we divided. Did we multiply or divide both sides by a negative number? Yes, we divided by negative 9 on both sides. Since both of these answers are yes, we reverse the symbol. It was less than, it is now greater than, and 36 divided by negative 9 is negative 4. Okay, now take a look at the screen. We think that the answer is t is greater than negative 4. When I go to check the answer and check the inequality, I'm taking that answer, t is greater than negative 4, but I am plugging it in to the original problem. Some people ask me, well, we reverse the symbol in the answer. Should we reverse it when we check it? No. This is your answer. You had to reverse it to get the correct answer, but when you go to check it, you want to go back to the original problem. If you look back in the video or back at your notes, you could see that the original problem is negative 9t is less than 36. So first we just check the negative 4. We want to plug that in place of t and see if that's equal to 36. Negative 9 times negative 4 is 36. And these are equal, so that's true. Now we pick a number that's greater than negative 4, which would be negative 3, negative 2, negative 1, so on and so forth. To make it easy on myself, since negative 3, negative 2, negative 1, 0, I could just pick 0 here because anything times 0 is 0, and that's really easy to check. So negative 9 times 0 is 0. Clearly 0 is less than 36, so we are correct. Next example, negative 21 is greater than 3m. Again, separate your two sides. The variable's on the right this time, and so is the 3. It's multiplication, so we are going to divide by 3. Negative 21 divided by 3 is negative 7. Stop. Did you multiply or divide? Yes, we divided. Did you multiply or divide both sides by a negative number? The answer to this is actually no. Some people tell me, but the 21 is negative. Yes, that doesn't matter though. What the question's asking is, what did you do? Did you multiply or divide by a negative? No, we did not. We divided by a positive 3. So the symbol's actually going to stay the same here. The 3's cancel, bring down the m. Okay, now remember from the last video, this is a correct answer, okay? I don't want you to get confused, but what we need to do is reverse the whole sentence so that the variable is first. So I'm going to put the m over here. And then when I reverse the sentence, I have to reverse the symbol. So it's m is less than negative 7. Remember, these two things mean the same thing. I'm not reversing it because I'm dividing or multiplying by a negative. That has nothing to do with it. I already determined I do not have to flip it. But when I go to put the variable first and I flip the whole sentence, then I have to flip the inequality sign. So I think the answer is m is less than negative 7. And again, I want to check the answer, check the inequality. So m is less than negative 7. I plug that into the original problem. Negative 21, I want to see if that equals 3 times negative 7. This is negative 21. 3 times negative 7 is negative 21. So far we are correct. Over here, we want to pick any number that is less than negative 7. That could be negative 8, negative 9. Picture your number line. We're going to the left because we want numbers less than negative 7. So I will do negative 8. So this is negative 21, and I want to see if that's greater than 3 times negative 8, which is negative 24. That is true. If you're confused, look back at a number line. Negative 21 is actually greater than negative 24. All right, a couple more examples here. Got 2 more examples to be exact. So here we have t divided by negative 4 is greater than or equal to 7. Again, separate the two sides of your inequality. The t is on the left along with the negative 4, but this time it's attached with division. So we need to multiply by negative 4, and whatever we do on the left, we do on the right. That way, the negative 4's cancel. I bring down the t, and then I stop. Did we multiply or divide? Yes. Did we multiply or divide by a negative number? Yes, we multiplied by negative 4 on both sides. Since both of these answers are yes, I'm going to reverse the symbol. It was greater than or equal to. I change it to less than or equal to. And then 7 times negative 4 is negative 28. As always, check the answer, check the inequality. So we said the answer was t is less than or equal to negative 28. First, let's just check if the negative 28 is correct and if that's equal to 7. So negative 28 divided by negative 4 is 7. Those are equal, so that's true. Now I want to pick a number less than negative 28. However, I will be plugging it into this sentence right here. So I want this number to be divisible by negative 4. Not only does it have to be less than negative 28, so that would be negative 29, negative 30, so on and so forth, I also want it to be divisible by negative 4. So I could do negative 32, I could do negative 40. Those would be some of the easy ones. So that is divisible by negative 4. So let's take negative 40, easy. I know that that's divisible by 4, and it's also less than negative 28. And I want to see if that's going to be greater than or equal to 7. So negative 40 divided by negative 4 is positive 10, and 10 is greater than 7, so this is correct. Last example here, r divided by 7 is greater than negative 5. Separate your two sides. The r is on the left with the 7, and they're attached with division, so I'm going to multiply by 7 on both sides. The 7's cancel. I bring down the r and then stop. Did we multiply or divide? Yes, we did. Did we multiply or divide both sides by a negative? No, we did not. We multiplied by a positive 7, so my sign stays the same, and then negative 5 times 7 is negative 35. Probably sick of hearing me say it, but as always, you've got to check the answer and check the inequality. So we think the answer is r is greater than negative 35. First, let's just check negative 35. and see if this is equal to negative 5. Negative 35 divided by 7 is negative 5, and these are equal, so it's true so far. Now we need to pick a number that's greater than negative 35, but remember, we also want it to be divisible by 7. You could do a number that's greater than negative 35, like negative 34. It won't be divisible by 7, but it'll still work. You just probably want to have a calculator nearby because you're going to have a decimal answer. So let's make it easy on ourselves since we're just trying to do this quickly. It's actually pretty easy because I know that all the positive numbers are greater than negative 35, so I could just pick positive 35. Obviously that's greater and it's divisible by 7. And I want to see if that's greater than negative 5. So 35 divided by 7 would be 5. That is greater than negative 5, so that's correct.